Standard Locknuts are not compliant for isolated power system (EMT) conduit systems entering 4 square boxes or intervening enclosures. Additional grounding means is required per National Electrical Code Section 517.62C2, which states where the conduit is terminated at a 4 square box without a grounding lug or hub, an equipment grounding conductor pigtail shall be installed. Standard Locknuts are not compliant for critical branch EMT conduit systems entering 4 square boxes or intervening enclosures. Additional grounding means is required per 517.62A, which states equipment grounding conductor shall be installed in accordance with 250.118. Section 250.118 requires that the equipment grounding conductor be connected to the equipment grounding terminal of the device. Standard Locknuts may be compliant for normal branch EMT conduit systems entering 4 square boxes or intervening enclosures. If the Locknut is listed as a grounding device per Underwriters Laboratories 467 and is properly installed, it can provide a reliable grounding path. However, it is recommended to use an equipment grounding conductor pigtail in all cases to ensure a redundant grounding path. The statement that standard Locknuts are not sufficient for feeders is likely based on the following sections of the National Electrical Code. Firstly, 250.148 if standard Locknuts and bushings shall not be used as grounding connections for ferrous raceways, auxiliary gutters, or cables. Secondly, 250.148 conduit bodies and fittings that are used to connect ferrous raceways, auxiliary gutters, or cables shall be listed for grounding. These sections apply to feeder raceways, which are not explicitly defined in the National Electrical Code but are generally understood to be raceways that supply power to an entire building or area. The isolated power, normal power, and essential generator backup power system should be grounded separately according to Article 700 of the National Electrical Code. The 120 volts equipment grounding conductor wire should be connected to the grounding electrode system at the service entrance. In operating rooms where general anesthesia is used, electrical safety is paramount. Grounding is a critical aspect of electrical safety. Let's delve into the requirements for grounding electrical metallic tubing, known as EMT, conduit systems in operating rooms, particularly focusing on the use of standard Locknuts and alternative grounding methods. We will examine the requirements of the National Electrical Code, specifically Section 517.62 and other relevant sections, to determine the compliance of standard Locknuts in various scenarios. We'll address grounding requirements for isolated power systems, critical branch systems, and normal branch systems, each often present in operating room settings. We will also consider the information from the Source Grounding Book, a resource that highlights the limitations of standard Locknuts in certain grounding applications. Isolated power systems are designed to minimize the risk of electric shock. They prevent direct ground path, thus limiting leakage current that could flow through a person in contact with electrical equipment. In an isolated power system, standard Locknuts are generally not considered compliant for grounding EMT conduit entering 4 square boxes or other enclosures. The National Electrical Code Section 517.62C2 provides specific guidance. Where the conduit terminates at a 4 square box lacking a grounding lug or hub, an equipment grounding conductor pigtail must be installed. This means that a separate grounding wire, the pigtail, connects the enclosure to the grounding system, ensuring a reliable low impedance path for fault current. Critical branch circuits serve essential loads such as lighting and life support equipment, which must remain operational during power outages. For critical branch EMT conduit systems, standard Locknuts are also typically considered non-compliant for grounding. National Electrical Code Section 517.62 dictates that equipment grounding conductors be installed in accordance with Section 250.118. Section 250.118 lists acceptable grounding conductors, and more importantly, Section 250.118 mandates that the equipment grounding conductor be connected to the equipment grounding terminal of the device. This connection is vital for providing a safe path for fault current. Normal branch circuits supply general-purpose receptacles and equipment. For normal branch EMT conduit systems, the compliance of standard locknuts depends on their listing and proper installation. If a locknut is listed as a grounding device according to Underwriters Laboratory Standard 467, and it is correctly installed, it can provide a reliable grounding path. However, even when compliant, it's recommended to use an equipment grounding conductor pigtail to ensure a redundant grounding path. Redundancy adds an extra layer of safety, mitigating the risk of a single point of failure compromising the grounding system. The SO's grounding book likely refers to National Electrical Code sections 250.148 and 250.148E when stating that standard locknuts are insufficient for feeders. Section 250.148 explicitly states that standard locknuts and bushings shall not be used as grounding connections for ferrous raceways, auxiliary gutters, or cables. Section 250.148E requires conduit bodies and fittings used to connect ferrous raceways, auxiliary gutters, or cables to be listed for grounding. Feeders, in this context, are raceways that supply power to an entire building or a substantial portion thereof. The National Electrical Code requires isolated power, normal power, and essential generator backup power systems to be grounded separately, adhering to Article 700. This separation prevents the propagation of ground faults between systems, enhancing overall safety. The 120 volts equipment grounding conductor wire must connect to the grounding electrode system at the service entrance. This connection ensures that all grounding paths ultimately tie back to the same grounding electrode system, providing a common reference point for electrical potential. In summary, while standard locknuts may be permissible for normal branch circuits if listed and properly installed, they are generally not compliant for isolated power systems or critical branch circuits in operating rooms. The use of equipment grounding conductor pigtails and adherence to the requirements of National Electrical Code sections 517.62, 250.118, and 250.148 are essential for ensuring a safe and reliable grounding system. In electrical installations, a grounding system is a critical safety measure designed to protect individuals and equipment from electrical hazards. In operating rooms, where sensitive medical equipment is used and patient safety is paramount, the grounding system must be particularly robust and reliable. Electrical metallic tubing (EMT) is a common type of conduit used to protect electrical wiring in buildings. When EMT is used as a grounding conductor, the connections between EMT sections and between EMT and enclosures must be properly made to ensure a continuous, low-impedance path to ground. Locknuts are commonly used to secure EMT to enclosures such as junction boxes and electrical panels. However, standard locknuts may not provide a reliable grounding connection, especially in critical applications like operating rooms. Grounding locknuts, also known as grounding bushings, are designed to provide a secure and reliable grounding connection between EMT and enclosures. These locknuts have a sharp teeth or a collar that bites into the metal of the enclosure, creating a low-impedance path to ground. In operating rooms, isolated power systems are often used to reduce the risk of electrical shock. An isolated power system is a special type of electrical system that does not have a direct connection to ground. Instead, it uses an isolation transformer to create a floating electrical supply. This reduces the amount of current that can flow through a person who comes into contact with an energized conductor, thereby minimizing the risk of electrical shock. However, isolated power systems require a robust grounding system to ensure that any fault currents can be safely conducted to ground. In operating rooms, electrical equipment is often powered by both normal power and essential generator backup power. Normal power is the standard electrical supply from the utility company. Essential generator backup power is a secondary power source that is used to provide electricity to critical equipment during a power outage. Both normal power and essential generator backup power must have a properly grounded system to ensure electrical safety. The National Electrical Code (NEC) is a set of standards for the safe installation of electrical wiring and equipment in the United States. The National Electrical Code provides specific requirements for grounding electrical systems in operating rooms. These requirements are designed to ensure that the grounding system is robust and reliable, and that it protects patients and medical personnel from electrical hazards. National Electrical Code Section 517.62, Grounding in Anesthetizing Locations, provides specific requirements for grounding electrical systems in operating rooms and other anesthetizing locations. This section requires that all metal parts of electrical equipment that are likely to become energized be grounded. This includes the metal enclosures of electrical panels, junction boxes, and equipment. The equipment grounding conductor must be sized in accordance with National Electrical Code Table 250.122, minimum size equipment grounding conductors for grounding raceway end equipment. This table specifies the minimum size of the equipment grounding conductor based on the size of the overcurrent protection device protecting the circuit. The equipment grounding conductor must be connected to the grounding electrode system at the service entrance. This connection ensures that all grounding paths are connected to the same grounding electrode system, providing a common reference point for electrical potential. In addition to the requirements of National Electrical Code Section 517.62, there may be additional local or state regulations that apply to grounding electrical systems in operating rooms. It is important to check with the local electrical inspector to ensure that the grounding system meets all applicable requirements. The SOAR's Grounding Book is a valuable resource for understanding grounding principles and requirements. This book provides detailed explanations of the National Electrical Code grounding requirements and offers practical guidance on how to design and install effective grounding systems. It is important to note that standard Locknuts may not be suitable for use as grounding connections in all situations. The National Electrical Code Section 250.148 states that standard Locknuts and bushings shall not be used as grounding connections for ferrous raceways, auxiliary gutters, or cables. This is because standard Locknuts may not provide a reliable grounding connection, especially in situations where the connection is subject to vibration or corrosion. Conduit bodies and fittings that are used to connect ferrous raceways, auxiliary gutters, or cables must be listed for grounding according to National Electrical Code Section 250.148. This means that the conduit bodies and fittings have been tested and certified to provide a reliable grounding connection. When installing EMT in operating rooms, it is essential to use proper grounding techniques to ensure electrical safety. This includes using grounding locknuts or grounding bushings to connect EMT to enclosures, sizing the equipment grounding conductor in accordance with National Electrical Code Table 250.122, and connecting the equipment grounding conductor to the grounding electrode system at the service entrance.